All right, great job. You guys have gone ahead and answered the warm-up question, and we're going to move on to the next part. We want to find out what's wrong with this machine. We're in lesson 4.2, analyzing claims and evidence. And today, you're going to be able to apply what you've learned about phase change at the macro scale, the big picture, and the micro scale, which is under a microscope, the little picture, to analyze data in order to support a claim about what could be wrong with the liquid oxygen machine. So you gave me a lot of good information in the warm-up. Some of you folks on the second tank saying it might not be cooling enough, or maybe it cooled too much, or maybe the first tank will hold less energy because it's going through a phase called condensation. That's good. The first tank is going through condensation. What is that? Going from a gas to a what? A liquid, right? Good. Going from a gas to a liquid. Now, we're going to be interpreting the claims now. There are 3 claims you're looking at. Now, the claim 1 is that there's frozen water in tank 2. And it's blocking some of the oxygen from going into tank 3 because it's blocking the pipe. Now, claim 2 is that some of the liquid oxygen evaporated in tank 3. And that would be because what? There's not it's heating too much and not, or maybe not cooling enough. Claim 3 would be that some of the oxygen did not condense in tank 2, which means it didn't turn from a gas to a what? Liquid. So it could have some of it remained being a gas, therefore not producing enough liquid oxygen in tank 3, which is what? Rocket. When I say rocket, you say fuel. Rocket. Rocket. When I say rocket, you say fuel. Rocket. Rocket. Okay, good. Now moving on. Today we're going to interpret these visual claims to understand more about the technician's ideas for why the liquid oxygen machine may not be working. This is going to be on the Jamboard, which I posted to Google Classroom this morning. So you can go ahead and open it up on a separate tab, the Jamboard. We're going to be referring to that, and also open your books to page 105, where you annotated the diagram from yesterday. What page do I want you to open to, class? 105. Very. It's page 105. Thank you. So, with the partner, you're going to compare each visual claim on the Jamboard to your annotations on page 105 at the same time.
105.
Yes. Yeah. So you're going back to 4.1. So, lady, please open your work to page 105. And thank you. Now, the diagram from yesterday you annotated shows how the machine normally works, what it's supposed to do. So, according to claim 2, the liquid oxygen evaporated in tank 3. So I wonder how that's different from what normally happens in tank 3. What I'm going to do is show you on the Jamboard. Okay, we're going to mix these up to see where these could possibly go. Notice some of these says supports or you can write supports or refutes. But in this case, I think each of these evidence cards would support one of the claims. Now, does your Jamboard already have this on it, cooled, more cooled, heated? Okay, then go ahead and add text boxes where you have that there to help you understand it at this time. Who does not remember how to add a text box in Jamboard? Well, class isn't there. Okay, Lyndon, will you help, please? Okay, try refreshing your page first. Okay, so you can annotate here too. Here I've added that we know the air, like the air we're breathing, is going into the first pipe. Mixed in with gaseous nitrogen and oxygen. So we have air, nitrogen, and oxygen going into the first tank. All the gases are going into the top pipe. are coming out of them. All the liquids are coming out of lower pipes. Make sense? So, air, nitrogen, and oxygen is going through here. This is cooled, causing the H2O water to condense, which is going from a gas to a what in condensation? Gas to a liquid. Very good. It's going from a gas to a liquid. So, this liquid is then cooled even more. Okay? It's cooled more. Well, the gas is cooled, gas to a liquid. The liquid is then transferred to tank number 3. And tank number 3, it's heated some. This causes the nitrogen to go from a liquid to a gas. And what do we call that phase change? From a liquid to a gas. Camila. Evaporation. Very good. That's evaporation. So it turns into a gas. The nitrogen comes out the top pipe. Remember, all the gases are coming out of the top pipes. And all the liquids are coming out of the lower pipes. Because, you know, like hot air rises, that's a gas. So that's why they're coming out of the top pipes. That kind of helps you understand what's going where. Manuel, let me have you move over here next to Stephanie. Thank you. Okay. So that's what's happening here. Is this, we're in RGZ OAL, correct? All right. So for our next part, I can see that oxygen usually remains a liquid in tank 3, but I can ask my partner questions I might have and record some of my thinking. Okay, so as we move through this part, this is a card sort. So you're going to take each claim, look at it with your partner, compare each claim on the Science Seminar visual claim sheet to your annotated diagram on page 105. That's why you have page 105 open. I will check. If you're not on page 105, you're losing points. Please open to page 105. Okay, so with your partner, who you're sitting next to, discuss the following questions for each claim. Why would the situation, cause less liquid oxygen to be produced? And when you answer the question, annotate it on the Jamboard by adding a text box. And remember, to add a text box, go back to your Jamboard and then click on the T in a rectangle and just put it anywhere and start typing. You can drag it open, make it bigger or smaller. You can move it around and you can change the size of the font. Okay, all those things. Got it? So the second question you're going to discuss with your partner is, what could be going wrong in the tank to make this happen, this situation? Okay? Again, you can add more annotations both to page 105, the diagram, keep it open, and also to directly on the Jamboard. Okay, so I want you to tell me, what am I asking you to do with page 105 and the Jamboard, and with your partners? So respond. Keep in mind, I can see exactly who's writing what by name. Okay, right? Just start writing, and we'll see what you think. I will correct you if you get it wrong. Again, write what I want you to do with the Jamboard and your partner and page 105. Don't lose any points. You put gibberish, your grade went down. Can someone repeat what I'm asking you to put on the Jamboard? What are the instructions I've given you before the Jamboard on page 105? What are you supposed to do? Who can answer the question? What are you supposed to do? You're taking it's an evidence card sort. We've done this before. You're trying to fit the evidence cards to either claim 1, claim 2, or claim 3. And you're also looking at page 105, which has the diagram that you annotated yesterday. So good, we have to annotate and take the evidence cards to claims 1, 2, or 3. Okay. We are to continue annotating on 105 and fitting evidence card to the claim 1, 2, or 3. That's correct. Is your computer working okay? Don't make so much noise. I don't see any letters. Oh, you're using that? Oh, okay. Thank you for clarifying. I wasn't sure what was happening. Are you done? Don't speak gibberish either. Yiddish maybe, but not gibberish. That's another language. All right, that's good enough. Is it clear what I'm asking everyone to do from these responses? Does anyone have any question about what I'm asking you to do? No. All right, I'm going to give you a few minutes to go ahead and first start sorting out the cards and annotating them. So we're going to move on from this part. Okay, so interpreting the evidence. We received some new evidence from the Universal Space Agency. We will work in partners and use your liquid oxygen machine diagrams to interpret the evidence. Let's look at an example of how you can annotate your liquid oxygen machine diagram based on evidence card A. Now, evidence card A says the temperature in tank 1 was slightly above normal. So tank 1 is supposed to cool the mixture. If it's slightly above normal, it's not cooling what? Enough. So what phase change is not going to completely happen? It's supposed to be condensing. So not enough of it is going to change from a gas to a liquid. In other words, liquid water. So if you have too much liquid water in tank 1, where is it going to end up in? Possibly. The other tank. What's the next tank? Tank 2. And then that is supposed to make it even cooler. So what is it going to do to that liquid water? Freeze it. Could it get stuck in that pipe and block it, right? Right. So let's analyze the evidence. So the temperature in tank 1 is slightly above normal. We already talked about it. So some of this water could have frozen right here and blocked that, causing not enough liquid nitrogen oxygen to end up over here. How did it freeze? Okay, well, remember, if you look at page 105 on your annotations, what does tank 2 do? It cools more. The first tank cools it. Tank number 2 cools it even more. This is like a refrigeration unit. This is like a freezing unit. So if there's water over here, it's going to end up, between here and here, it's cold and colder.
Where does the water be warmer?
How?
It's getting hotter.
Okay, this is cool, this is cooler. Where is it getting hotter?
In the start, it says it's slightly above.
In the pipe?
I know, you started saying it's slightly.
It says it's slightly
Yeah,
above.
it says slightly above normal.
Okay, alright, so what could be happening? Tank 1 slightly above normal, meaning this liquid water, instead of coming out here, freezes, blocking the pipe.
How? It's hot.
It just says slightly above normal. When it says slightly above normal, it means it's not cooling enough. Elizabeth, are you okay? Okay. Make sure you're sitting straight. Are we making sense?
Yes.
All right. Let me rephrase it. In tank 1, it's not cooling enough, which is why the temperature is slightly above normal. How it would normally operate is cooling. So if it's not cooling enough, then some of this liquid water is staying as water vapor and ending up somewhere here and freezing. Does that make sense?
Yeah.
Okay. Remember Dr. Flores said one of the tanks has a problem with the temperature control. So it's going to be either too hot, too cold, and it's throwing off a whole process. Let's work with this some more. If we look at our Jamboard over here, okay, what's happening here? Air, nitrogen, and oxygen is going in tank 1. Now normally, it gets cooled right here. It's like a refrigerator. When that's cooled, the water vapor turns into liquid water and it drains out of this pipe. Remember, all the lower pipes are transporting liquid. Okay, that's the first thing you need to know. Once this nitrogen and oxygen over here is cooled even more, so the nitrogen and oxygen gases turn into nitrogen and oxygen liquids. Okay, liquids, and that's transferred in this lower pipe to tank 3, which is then heated some, causing it to turn to what? From a liquid, the nitrogen turns from a liquid to a what? Gas. And that goes here, it separates it from the oxygen, which is a liquid, which comes out the bottom pipe and ends up being rocket fuel, which is what we're trying to make.
Mm-hmm.
We have to separate the nitrogen and the air and any water in there from the oxygen and convert the oxygen to a liquid to make pure liquid oxygen. Does that clear it up?
Yes.
All right. So what I want you to do is tell me any questions you have right now. Like Cameron asked some great questions. Tell me any questions you have right now. Okay, one question I see is, what would happen if the water is boiling hot and sends hot gas to tank 2? Okay, well, that's going to be water vapor that's going to go to the second tank. And if it's colder than tank 1, then that water vapor is going to turn either to liquid water or freeze into solid ice. Make sense? Another question. Wouldn't the ice melt and turn to liquid in tank 1? Well, tank 1 is a refrigerator. Even if it's slightly warmer, like sometimes your refrigerator, who has a refrigerator at home and it was broken, it wasn't cooling enough, and they had to come out and repair it or replace it? 1, 2, my hand is up. Okay, everybody sit nice and straight. Okay, if there's more than one problem in the machine, then, well, what we're concerned about is fitting the evidence cards to the right claim, because they've given us a limited set of possibilities, and that wasn't one of them. So that person is a brilliant genius that's thinking outside of the box. But we're going to work, in this case, within the box they've given us, with the choices they've given us. Okay? If we have to take the water out and separate the nitrogen and oxygen, how does it turn into fuel if you have to mix them together to make the fuel? Well, what is the fuel made of? Pure what? This is not ice fuel. Well, liquid oxygen is the fuel. Who has a hard time wrapping that around your mind? Liquid oxygen is the fuel. Even oxygen gas, pure, will kill you. It's toxic to us. We cannot breathe pure oxygen. Okay? So the air we breathe is only about 1/5 oxygen. It's mixed in with nitrogen and other, carbon dioxide, carbon monoxide, a lot of other gases. Okay? Make sense? Yes. To the machine? Oh, you're asking for breathing in gases? We're not breathing in liquids, or we'd be dead, right? We have drowned. So yes, remember, we breathe in
What do we mean?
oxygen from the. We're breathing in air. Okay, listen. No. This is like the third or fourth time I said it, because in your mind you're thinking we're breathing in oxygen. That's a common misconception. Again, the air right here is about 23% oxygen. It's mixing with other things like carbon dioxide from the plants, carbon monoxide from the smog, nitrogen, and other things. When we breathe in this air, it goes in through our lungs, it's pumped through our heart, it interfaces with our lungs. Here you have your blood on the bottom here, and above it is the gases from, what happens is the oxygen in the air you breathe in is absorbed into your blood. And then your heart goes lub-dub,